Enthalpy of adsorption. In the previous class, you understood the types of adsorption and the nature of adsorption. Now, today we are going to understand the enthalpy change taking place during adsorption. Adsorption is exothermic in nature, that is, delta H enthalpy change is negative. We can understand it in a simple way because here the molecules of adsorbate, they are getting associated on the surface of adsorbent. The adsorbate molecules, they accumulate on the surface of adsorbent, and how they get accumulated on the surface of adsorbent? By some physical forces like van der Waals forces or with the help of some chemical forces. So as there is some interaction or bond formation taking place between adsorbate and adsorbent, the nature of adsorption is exothermic, or the heat change is negative. Wherever there is bond formation, you know that the nature of the enthalpy is negative. Change in enthalpy is negative. And since the adsorbate molecules, which are gases, they are accumulating on the surface of adsorbent, it means the randomness is decreased. There is decrease in randomness, or they are becoming more orderly. Hence, the entropy change in case of adsorption is also negative. There is decrease in entropy. Final entropy becomes less than the initial entropy, and hence delta S is negative. So, applying these two conditions on Gibbs-Helmholtz equation, del G is equal to del H minus T delta S. If we want to understand that what are the favorable conditions for adsorption, as you know, enthalpy change delta H is negative, it is negative, and delta S also is negative. So what will make delta G negative, or what will make adsorption spontaneous in nature? So both being negative, the temperature condition according to Gibbs-Helmholtz equation should be such that there is more extent of adsorption. So delta S being negative, delta H being negative, and the product T delta S becomes negative, and this negative becomes positive. So to be T delta S lower than delta H, T should be lower, or T should be smaller. So at lower temperature, or lower temperature or at lower temperature, the product T delta S will be lower, and hence as sign of delta H is negative and this is becoming positive due to negative sign of delta S, the delta G will be negative if temperature is low. So the same can be understood. We have discussed the two types of adsorption, physisorption and chemisorption. So low temperature will favor the extent of adsorption. Extent of adsorption is mathematically written by X by M, where X is the mass of adsorbate and M is the mass of adsorbent. So extent of adsorption versus temperature. In case of physisorption, it is observed that increase in temperature decreases the extent of adsorption. So this is the nature of graph we get. As you increase the temperature, the extent of adsorption is lowered. Reason that adsorption is exothermic in nature. So according to Le Chatelier's principle and according to Gibbs-Helmholtz equation, low temperature will favor the extent of adsorption. So for physisorption, when we draw the graph between extent of adsorption and temperature, you can see a descending curve. For chemisorption, if we study the extent of adsorption with temperature, the nature of graph is different. It is in this manner. It means the extent of adsorption, first it increases with increase in temperature. This you can see, there is increase in extent of adsorption on increasing the temperature, reaches a maximum, and then again at higher temperature there is decrease in its extent of adsorption. So as you have just understood that adsorption is an exothermic phenomenon, low temperature will favor the extent of adsorption. But why here the temperature increase is increasing the extent of adsorption when it is low? It is because initially the reactant molecules require some temperature to overcome the activation energy of reactants. So at higher temperature, as the number of effective collisions increases, that helps to overcome the activation energy of reactants. So initially increase in temperature is increasing the extent of adsorption because the reactant molecules have to overcome the activation energy barrier. And further increase or at high temperature, why the extent of adsorption is decreasing? Because thermodynamically adsorption is an exothermic phenomenon. So low temperature only will increase the rate of adsorption. And when temperature is very high, the rate of adsorption or extent of adsorption decreases. So from this we can understand the effect of temperature on the extent of adsorption. So you need to remember that adsorption by nature is exothermic. Delta H is negative and entropy change also is negative, and both being negative at low temperature only, the adsorption is favorable, or at low temperature delta G will be negative. Now this is the effect of temperature we understood on the extent of adsorption. Now what are the other factors that affects the extent of adsorption? One is the nature of adsorbate. Nature of adsorbate. Secondly, it is nature of adsorbent. Nature of adsorbent. Third is temperature. Temperature, its effect we have already discussed here with the help of graph. And fourth is pressure. We are here discussing gas solid adsorption, where the adsorbate is gas and adsorbent is solid. One of the component, that is adsorbate, being a gas, hence pressure has an effect on extent of adsorption. So nature of adsorbate, that is nature of gas, nature of adsorbent, that is nature of the solid on which the adsorption is taking place, then temperature and pressure of the gas, and of course the surface area of the adsorbent. Surface area of the adsorbent. So these are the main factors on which the extent of adsorption depends. Now let us see how these factors affect the extent of adsorption. First of all, nature of adsorbent. So adsorbent is the component which is providing surface for adsorption to take place, and in case of solid gas adsorption, the adsorbent is a solid. So which solids have higher extent of adsorption, or they act as good adsorbents? Those solids which have larger surface area. So the last factor, surface area of the adsorbent, it is including in this factor only nature of adsorbent. So those adsorbents which have larger surface area, they have more extent of adsorption. Another thing is, if we want to increase the surface area of the adsorbent, there are some ways by which we can increase the surface area of the adsorbent. You have studied that D block elements, which are metals, they are good catalysts. They act as good catalysts because of the reason that they have larger surface area. On the other hand, charcoal is also a common adsorbent which is used in solid gas adsorption. So charcoal, its extent of adsorption can be increased or enhanced by making it activated charcoal. So how a charcoal is made, an activated charcoal is that it is heated in vacuum at a particular temperature so that it loses all its moisture content and becomes porous. So once it becomes porous, its extent of adsorption is increased because the surface area is increased. Likewise, in electrolytic cell or in standard hydrogen electrode, you have studied that platinum foil acts as an electrode, and that platinum foil provides only surface for the reaction to take place, for the electrode reaction to take place, and its activity is increased by making it granular, or you can say granulated platinum. So these are some ways by which we can enhance the activity of the adsorbent, which is acting as surface, or which is giving the surface for adsorption to take place. The second factor is nature of adsorbate. The next factor is nature of adsorbate. Now here you know that adsorbate is gas. So which gases they have larger extent of adsorption and which have less extent of adsorption? Those gases which are easily liquefiable, or those gases which can be compressed easily, their extent of adsorption is more. The gases which are easily liquefiable and the gases which are having high intermolecular or stronger intermolecular forces of attraction, they are more adsorbed compared to the gases which have weak intermolecular forces. So the gases of 18th group, inert gases, they are less adsorbed compared to gases which are polar in nature, like ammonia or sulfur dioxide. So gases which have high compressibility factor, which can be compressed easily, can get adsorbed more. Those gases which cannot be liquefied easily, those gases which have weak forces, interparticle forces, intermolecular forces, their extent of adsorption is less. Temperature, again let us revise that in case of physisorption, increase in temperature decreases the extent of adsorption, and in case of chemisorption, the rate of adsorption or extent of adsorption first increases on increasing the temperature, and at very high temperature the extent of adsorption again decreases. This I told you why initially there is increase in extent of adsorption is the reactant molecules try to overcome the activation energy. So, and the most important factor in solid gas adsorption is pressure. So this we will study in detail, understanding the effect of pressure on the extent of adsorption.